Hi guys, here is section 9.2. We're doing some polar graphs. The first part of polar graphs, I think you all got pretty well, so I'm going to skip this. It's just a matter of identifying polar curves based off the equations. I guess it won't identify it, just in case someone didn't really understand what was going on in class. All right, for number one, it's got an r squared in it. We know anything that's got the r squared, that's automatically a lambda skate. Okay. Then I'm going to look for number two. It's got 2 theta. So whenever this guy here is not just theta, so if it's a 2 theta, 3 theta, 4 theta, 5 theta, 6 theta, some multiple of theta, we know it's going to be a rose. So this is a rose, and if you look down at number 7, this one is a rose as well. For number 2, because the number in front of theta is even, it's going to have twice as many petals. So instead of it having 2 petals, like we would think, it's going to have 2 times 2, which is 4 petals. So this guy here is going to be a 4-petal rose. Whereas for number 7, this guy here is a 7 theta. If it's an odd number, then it's exactly what it says. If it's an odd number, it's going to be 7 petals because it says 7 theta. So if it was 5 theta here, sine 5 theta, that would be a 5-petal rose. If it's 3 theta, that's a 3-petal rose. For even, if it was 4 theta, that would be an 8-petal rose. If it was 6 theta, that would be a 12-petal rose. If it was 8 theta, 8 times 2 would be a 16-petal rose. So we double it if it's even, it's exactly the same if it's odd. Now if you look at number 3, number 6, number 8, and number 10, all of these guys, whoa, that did not work well, sorry. All of these guys have some number, and then it's plus or minus a sine or a cosine. So for all of these guys where you see the addition or subtraction symbol in there, those are going to be limesons. A limason. And a limason has 4 different varieties. And if you go back to here, you'll notice the different varieties here. And so what we're looking at is the ratio of A to B, the ratio of the first number divided by the second number. So for this one, my A over B is 4 over 3, which is 1 1/3, so 1.333. If I go back here, I want to know 1 1/3 is not less than 1, it's not equal to 1, it's between 1 and 2. So this guy is a dimpled limason. Dimpled limason. All right, looking at number 6, A divided by B would be 3 divided by 3, which is 1. When A divided by B is equal to 1, then we have a cardioid, which means it's a heart-like shaped circle, which doesn't make sense, but I think it will when you graph it. All right, 1 minus 2 sine theta, this is going to be 1 over 2, so that's 1/2, that's less than 1. So we have an inner loop limason, so the circle shape with a little loop on the inside. Let's call that a looped limason. And then finally, 2 plus cosine theta, that's 2 over 1 if 2 is bigger than here. Whoop, let's go back. Here, 2 over 1 would be 2. If A over B is greater than or equal to 2, which we're equal to 2 here, it's a convex limason. All right, for 5, when r is equal to 4 theta, so if you've got 4 theta but we have no cosine or sine, that is a spiral of Archimedes. All right, and then that leaves us 4 and 9. And 4 and 9, notice they have a cosine, they have a sine, but we don't have a multiple angle. If it was a multiple angle, then we would have a rose. And then we're not adding or subtracting something to the front of it. Those are our limasons. So these guys are just straight up old school circles. just written in polar form as opposed to rectangular coordinates. All right, so that's identifying and classifying polar curves. In the next video, I'll start doing some graphs.